So hey guys, in this video I'm going to teach you all about the PID loop. So this PID loop is based upon three terms: the P term, the I term, and the D term. So the P term stands for proportional, I stands for integral, and D stands for derivative. So the proportional sign over here, the proportional term over here is actually the proportional sign in mathematics. This sign, say A is proportional to B. This is same as this thing over here. So if we have a input as our MPU, a output as our TVC mount or the servos, this is the input, this is the output, then if we need to connect both of these, we need operator to complete this loop. And this operator, this first operator which we are going to talk about, is the P term, which stands for proportionality. So over here we can say that the final TVC angle is proportional to the sensor angle, sensor readings. So using simple maths we can say that the TVC angle is equal to some k, some constant multiplied by the sensor angle, and this constant over here is our P gain, and this gain is constant throughout the flight, throughout the code, and does not change. So this is the proportionality sign, the proportionality term in the PID loop. So now let's understand this using a graph. So we first have a set point. Set point, say this as 0 degrees or any other degrees. I'm saying it as 0 degrees as the set point. So we need the servo to be at this point, but we are actually over here. Let me draw this with another color. So we are actually over here. So if this rocket is a computer based rocket with no mechanical part, using the proportionality term itself, we can just multiply, keep on adding the proportionality sums, keep on adding the terms and reach to the set point. But in real world this doesn't work. In real world we have something called inertia and momentum, which causes the overshooting of the servo of the TVC mount, which is very bad for our rocket. So to encounter this problem, what we do is we add another term called the D term or the derivative term. You all must have learned this term, the meaning of this term, in 11th standard or 12th standard. Those who have not, for you all, this actually acts as a braking system to the proportionality term. If not understood still, I'll explain it again with a graph. So if we have a set point again over here and a actual point of our TVC, we start from here with a vector of A, okay, and we need a opposite vector which is not equal to the actual vector. Why it should not be equal? Because if it's equal, then the positive vector, negative vector, both equal vectors would get cancelled and the final angular velocity will be 0, and the TVC, the servos, will not at all move. That's why we need a smaller braking force, a smaller opposite braking force, which is our derivative term. So we have this vector positive, a smaller negative force. So a vector, the bigger vector, this vector, plus some with a negative smaller b vector, this vector, gives us the final PD loop. Yes, my friends, this is the PD loop itself, nothing more to it. So, what happens actually is, as this keeps on decreasing, at a point both of these vectors are equal, and at this point it becomes 0 and no change in position, which means the angular velocity is 0 over here at the set point. So with this we are completed with the PD loop of the PID loop, and this is as simple to understand. If you have not still understood, I would be doing a live stream where you all can sort out your doubts. So the next term is the integral term, the I term, which is not that important if your flights are very short duration. But if your flights are long duration and you all are not accurate with the calibration of the TVC or the sensors, you all need this term. So we can see this integral term. Actually, it's the integration or the summation of all the errors, the integral term. Okay. So if we have a position time graph, say if it is something like this, then the summation of all the errors over time, multiplied to the I gain, multiplied to a constant, and summation of all errors is actually your integral term over here itself. So with this we are completed with the P, I and D loop. Congratulations if you all have understood this, and a separate video will be coming on how to implement all these formulas in the code. So with this we come to an end to this video. Very big thank you for the 1K subscriber family which we have completed on YouTube. So and this is our 7 signing out.